This lecture is part of a Udemy course entitled Design of Wastewater Treatment Plants for On-Site Projects. You will learn how to fully design a treatment plant for small to medium-scale projects. You can find an 80% discount promo link in the description box. Hello everyone and welcome to this new wastewater treatment lecture that will be about the anaerobic filter. We will describe this process and we will see how to design it. Let's start by a quick overview. We will start by the concept of this wastewater treatment system. An anaerobic filter is considered as a secondary treatment. So for those who are not really familiar with the wastewater treatment stages, we usually have a pre-stage, which is the screening. So the wastewater would undergo screening. We will remove the very big particles like the branch of tree, like stone, for example. So any big material that might damage a wastewater treatment system and clog the pipes. Then we have a second or the primary stage, which is usually a sedimentation tank. That can be a septic tank. It can be an ABR, for example. It can be any system that would remove the suspended solids. So we will have the formation of a sludge. And also we will remove the floating materials. So the scum, anything that will float. So this is the primary treatment or the first stage of treatment. Then we have the secondary treatment. Usually in this secondary treatment, we remove organic matters. When we say organic matters, so the main pollutants like the BOD, like the COD, like nitrogen and phosphorus. So this is the bulk of the treatment in the secondary treatment. It can consist of aerobic systems. When we say aerobic, so we have the diffusion of air within the wastewater. And anaerobic systems, so we don't diffuse air, we rely on the biomass to treat the water. We will see these in this lecture. Then we have the tertiary treatment, which is the disinfection process that can be through chlorination. So simply we add chlorine or through UV disinfection, for example. Then you can dispose your water or reuse it depending on your local regulations and the water's quality. So when we say secondary treatment, an anaerobic filter comes after the primary treatment, and the main purpose of this anaerobic filter is to remove organic matters. It consists of one or more filtration chambers placed in series. So as you can see here, we have many chambers and we have a media. So this is the media. We have filtration media, and notice how the water is entering through the slunk pipe and it is entering at the bottom. So the water is flowing upflow. It enters from the bottom and it goes through this media, and then it will go into the second chamber and the same process will happen. Notice that this media is not placed at the bottom of the tank. It is somehow elevated. It is placed on a perforated slab. Notice this is a slab. It is perforated so that the water can enter through it, and it is placed at a certain height. This anaerobic filter unit, it is preceded by a settling or a septic tank. So notice we have a settler as a primary treatment, for example. So we are highly lowering here the total suspended solids that will form the sludge, and also the scum, so or what is commonly known as fat, oil, and grease, fog. So anything that can float, because these can clog the filtration material. And also the total suspended solids, also they can clog these filtration materials, and we will face a serious problem. Only the clean water and the clear water will go through the secondary treatment. We can also use a septic tank for a better or enhanced primary treatment. So a septic tank is usually it is made of 2 chambers. So it really looks like the settler, but we have 2 chambers for enhanced removal of total suspended solids, and the ideal primary treatment is actually the ABR, the anaerobic baffled reactor. I have already posted a lecture about the ABR, which consists of a series of settling tanks. We can go from 3 to 6 compartments in an ABR. You can have a look of this primary treatment if you are interested. So as I have already said, it requires an efficient primary treatment to avoid filter clogging. So ideally use an ABR, and you can use simple materials to build this anaerobic filter. You can use reinforced concrete, fiberglass, PVC, or even bricks. This system is actually ideal and is considered a DEWATS. When we say DEWATS, it means decentralized wastewater treatment systems. It is ideal in emergencies. So when we want to build a quick and efficient wastewater treatment system in refugee contexts, for example, in regions where we don't really have a centralized treatment for the wastewater in small communities, etc. We have 2 main processes that take place in this anaerobic filter unit. We have first the physical process. So obviously we have a filter, so some particles will get trapped within this filter media. So this is called a physical treatment. But most importantly, we have the biological treatment. So this is the bulk of the treatment, and this what will really help to highly reduce the BOD, or the COD. So these are the main pollutants, or one of the major pollutants of wastewater, and these are usually removed in the secondary treatment. So what will remove these 2 components are mainly the biofilm. What is a biofilm? Throughout the time, we will have the formation of a sticky biofilm, let's say, over this media. It will be made of good bacteria, let's say, and these bacteria will actually, throughout the time, they will get starved. They need food, and their food is actually the BOD and the COD, the organic matters. So this is why we have high reduction of these 2 components through the biological treatment. These biofilm will be formed anaerobically. So this is why we call it anaerobic filter. When we say anaerobic, so we don't have the presence of air. So as you can see, we don't have air blowers, we don't have air diffusion. We have anaerobic conditions. So anaerobic conditions, no air, and we will have the formation of anaerobic biofilm, which is a type of a bacteria that is formed in anaerobic conditions. And throughout these stages, we will have different kind of anaerobic bacteria. So this is why we have many stages, actually. You might think why we don't place all these media in one chamber. Because in each chamber, we will have different types of biofilm that will be formed. Because during the first stages, we will still have some sludge, we will still have a lot of pollutants, and throughout the stages, we will have lower pollutants, and different types of biofilms will be formed in each stage. Also notice an important component, which is the vent pipe. When we say anaerobic treatment, we might face some odors, some bad odors that we really want to avoid. So always pay attention on the vent to help the odorous gases to escape. Now let's check the media that is placed within the anaerobic filter. The types of media are really simple. So it can be simply plastic bowls. So as you can see here, it can be a PVC tube that are cut with a diameter of 10 to 25 millimeters. So what you are seeing in this picture. It can be plastic rings. It can be pumice. like what we are seeing here. So these light gravels that are a little bit perforated. We can use coconut shells, gravel. We can also place a different kind of media in one system. For example, for the first filter, we can use gravel, then use pumice, then use plastic. Okay, or in the same chamber, we can use different layers of different media. So we can start with the plastic, then the pumice, etc. But pay attention that the sizes should range from the largest to finest. So we start by the largest till the finest media. Now we will go through some recommendations to have a successful wastewater treatment system. Always provide good contact between the media, so the filling material and the wastewater. You can use bowls or tubes with lots of perforations to offer large contact area and wide passages for the wastewater. Also, we need uniform wastewater distribution. So we need to distribute the wastewater at each point of the filtering media. We don't really want short circuiting, and we don't want that only one area to be used, or the wastewater only to cover one area. We need uniform distribution. Also pay attention to uniformly perforate the bottom slab. Okay, so we have a slab here. This can be a concrete slab that must be uniformly perforated. So this is what an anaerobic filter looks like in real life. Notice this is an anaerobic filter that is made out of bricks. For example, so easy material and easy construction. And this is a reinforced concrete anaerobic filter. Notice the pipes. So we have many pipes placed in series in one chamber. And notice this a slab. We have a perforated slab, and also here a perforation so that the pipe can enter. So because we will have here a long pipe, and also notice here we have a big opening and a concrete like pipe for dislodging. So when we want to dislodge, the dislodging pipe enters through this pipe. So this is another picture of reinforced concrete anaerobic filter. Notice the openings at the top of each section. So each section must have access. And this is like the final result of each chamber. We have the pipes, the inlet pipes, the slab, and just we need to place the media. So we fill this chamber with media and we are done. For the performance, we can expect a COD removal of 65 to 90%. So this is a good performance. Also a BOD removal up to 90%. Total suspended solids removal up to 90%. Of course, we are considering here that we are using a good primary treatment. Nitrogen removal is pretty low, up to 15% only, and also pathogen reduction is very low. We have to use a tertiary treatment, so chlorination, UV, and even you can consider the use of a constructed wetland. Let's go through the advantages and disadvantages of an anaerobic filter. No electrical energy required. We don't have any mechanical component. Also low capex and opex. We have low capital cost. We don't really have expensive material. And also OPEX, the operation costs are also very low, since we don't have mechanical equipment, we don't have energy consumption, so the operation is pretty low. Long service life. Also we have a high reduction of BOD and COD. Low sludge production. And the sludge is stabilized. This is an important factor, and also moderate area requirement. Disadvantages, it might require expert design and construction. Also, we have long startup phase due to slow growing of the anaerobic biomass. Like any other anaerobic system, the startup phase or the formation of the biomass can take 6, 7, or even 8 months. So it is pretty long. It's a pretty long startup before we see results. Also, we have low reduction of pathogens and nutrients. There is also a risk of clogging. So the media can clog depending on pre and primary treatment. And also, after some time, we have to remove and clean the clogged filter media. And this is a bit complicated. So regardless, even if the primary treatment is super efficient, after a certain time, after the formation of a thick biomass, we will have to remove this filter because it would be clogged, and clean it or even replace it. Now for the design. So we will see what are the design requirements. So we have to consider a number of baffles of 3 to 6 baffles. So 3 to 6 chambers after the primary treatment. Okay, so around 3 to 6 stages. The hydraulic retention time in all these stages is 12 to 36 hours. From this hydraulic retention time, we can simply calculate the volume. So the volume, it is equal to the flow, Q, so how much water we are treating per hour, times the hydraulic retention time, HRT. So you can get the volume in meter cubes, and this would be the total volume, okay? Not the volume of each chamber, this would be the total volume, and then you divide it for each chamber. The material that would be placed in these chambers should provide between 90 to 300 meters square of surface area per 1 cubic meter of occupied reactor volume. The typical filter size, it ranges from 12 to 55 millimeters. Also, you must always make sure that all the chambers are accessible through access ports for maintenance, desludging, and media removal. And as I have already said, the tank should be vented. You have to consider a good ventilation system to allow the release of the odorous and harmful gases. Now, what we are seeing here is a typical section of one chamber of anaerobic filter. So this is the media. In this case, it consists of a perforated plastic balls or small tubes. We have also the bottom slab, which is uniformly perforated. We have also the water that is covering the media. So make sure you have at least 10 centimeters of water covering the media. And also we have what is called as freeboard. In this case, it is the gas space, and even for maintenance, we require at least 30 centimeters between the top of the water and the top of the chamber. So as we have already seen that we have many pipes in each chamber, and these pipes are long pipes so that the water would enter at the bottom, and always consider a spacing between the baffle pipes 25 to 45 centimeters. Now we will go through the operation and maintenance. The anaerobic filter requires a long startup period, so between 6 to 9 months to reach full treatment. So we have slow growing anaerobic biomass that are being established on the filter media. If you want to reduce this startup time, you can take some anaerobic media from another treatment system. Like for example, you can take some sludge from a septic tank and place them onto this filtering media to just to enhance or to make this biomass formation a bit faster. Also, the scum and sludge levels, they need to be monitored to ensure that the tank is well functioning. So from time to time, just have a look on the scum and sludge levels, and if you need to dislodge the system. Also, you have to pay attention that when the efficiency decreases, then the filter must be cleaned. So you have two options, or you can run the system in reverse mode, so what we call it as backwashing, or you simply remove the filtration media and you clean them. And also here, pay attention that when you clean this media, you will remove this biomass. So also you will have to wait 6 to 9 months, another 6 to 9 months, so you have the formation of this biomass. Thank you for watching this lecture. Please don't forget to like and subscribe.